Okay, so today is February the 2nd, 2015. Today's lesson is called Introduction to Calculus. Okay, so as you heard me say before, we're going to start with one unit on the fundamentals of calculus, and then we're going to do 3 units on vectors, and the midterm will be just on the vector part. What is calculus? Calculus is study of change. In advanced functions, I sat through Mr. Lace's advanced functions class last year. Do you remember that, Ben? I was in the back of the class, remember, sitting in the back corner there often. There are a few guys in there. And every unit they would talk about average rate of change. You guys remember that from last year? Okay. And secant line and all that sort of stuff. And I growled on the inside because it was so painful. Do you remember doing a question that looked something like this? Does that look familiar to anybody? Do you remember that? Okay, so that what they were trying to do for these was they were trying to find the instantaneous rate of change, right? That's what they were attempting to do. You start with a secant for 2 points, and what you're trying to do actually is to get the points close and closer together. Okay, that's what calculus actually is, when the points are actually the same thing. Okay, so what we're looking for this, it's going to be instantaneous rate of change is the main thing that we're finding. And we'll talk lots and lots and lots about instantaneous rate of change. Okay. Let's do a little bit of basic algebra. We need to make sure you guys have mastered from grade 12 advanced functions. This especially goes true if you haven't taken advanced functions in a year. Who is not fresh out of advanced functions? Can you raise your hand, please? Okay. That's not bad. If I'm going too slow for the rest of the class, that's fine. Okay, but I just got to be gentle with the people that haven't taken it in a year. So. Okay, so we're going to say factoring special polynomials come first. Okay, now, here. Let's say I were to give you a question like this. Do you recall from advanced functions how you would factor something like that?
X cubed equals 64, and then take the.
That would be to solve it if it was equal. But how would we just factor this?
Can you do differences there?
No, not because they're not squares, so it's not going to work. That's just how would you factor out
In advanced functions, there's some difference of cubes.
Well, this is what we're getting into here. So, how do you factor a cubic for advanced functions? I don't know how to factor a cubic. Go ahead. Yeah. Yeah, very good. Okay, so what's going to happen is we're going to begin by using the factor theorem, which is what you were talking about, F of P over Q, right? The factor theorem. And then use synthetic or long division. Now, I'm a cruel human being. I just said it. You'll be thinking it yourself many times this year, okay? I'm going to make you do long division today, okay? Mainly because you need to use it for a few things in this course. Secondly, because people forget it. They learn synthetic and they never go back to long division ever again, okay? So I'm going to do long division for this. Okay, so basically what the factor theorem is a reminder. Most of you guys just had your exam, so this should be a piece of cake. Okay, not you, not you. Matt, did you remember the factor theorem at all? Okay, that's okay. Christina, do you remember the factor theorem at all? Okay, does Karen remember the factor theorem? Go ahead. Yeah, then A is, yeah, so A is a root. So I'm going to say X minus A is the factor. should be. Okay, so the thing is for this one, now I sort of snugged what Harry said at the beginning, but it actually made sense. When you're talking about x cubed equals 64 and then cube root, okay? Because when you're looking in this case, you want f of something to equal 0. That means you have to get this to be 64, right? So that would be 64 minus 64 would be 0. So what cube is going to give you 64? So the way you would check that is, which I'm going to do. By the way, if I'm going too quickly here or something doesn't make sense, somebody let me know. All right, Katie, since I found out that f of 4 equals 0, what does that tell me about the world? What is a factor? Nope, close though. 4 is a root. So what's the factor then? Somebody help her. It's okay. It's a first day. It's okay. What's the factor? X minus 4. Thank you. Now let me just say, you guys may use synthetic division. I'm going to do this with long division though, because I want to make sure that you guys can do this, because we're going to do a proof involving long division in about 30 seconds. Okay. Did anyone else not have this again? If you haven't, that's okay. That's your homework tonight. All right, so let's do some long division. The way you do long division is this. Okay, there is, Joe, one trick on this. How do I have to write, not you, how do you write x cubed minus 64? Very good. Okay, so it's going to go x cubed plus 0x squared plus 0x minus 64. All right. I may pick on Amy, I may pass on her, we'll see what I feel like. Do you remember the long division? Yeah. Okay, go ahead. Now, how'd you get x squared other than a lucky guess? Good. So what she did, so I'm just going to help as you're explaining that. So what she did, she needed to get x cubed. So x times x squared is x cubed. Okay, sorry to interrupt Amy. So what goes underneath here then? So just for how she got that again, x squared times x is x cubed, x squared times minus 4 is negative 4x squared. Laurel, what is, Laurel, sorry, I'm that person. Go ahead. What do we do next here then?
So 0 minus negative 4x.
Good. Great. Wonderful, tremendous. Oh, Jolena, is that right? Yeah. Jolena. What do we do next here now, please? No, well, because what we're going to, okay, close. What we have to do, we have to get rid of this now, right? This is the next thing. So I'm just going to bring this guy down. And then what you're thinking of is how many times does x go into 4x squared? So how many times does x go into 4x squared? 4x times, good. So it's plus 4x, right? Sorry, Karen, go ahead.
So just multiply the 4x by x minus 4,
Good.
you get 4x squared minus 16x.
Right.
And then when you subtract, you get 16x minus 64.
Okay, so, oh my goodness, hold on a sec. Wonderful. Okay, not everyone did this right away. Hold on a sec. Do we follow? Wonderful, by the way. Excellent. Tremendous. Okay. Is this coming back to people, I hope? Or someone okay? All right, Courtney, final step here is going to be what?
We have to find how many times x goes into 16x.
Good. How many times is x going to 16x?
16.
Good. So that should turn into 16x minus 64. And 0 remainder. Okay, why do we have to have 0 remainder? Anybody here? Why should we have to have 0 remainder? Right, because we were told this already, right? So there should be no roots. If you accidentally screw this up, sorry, if you accidentally mess this up, you will not have a remainder there, and that's where the issue comes in. Okay, so what we learned so far then is x cubed minus 64 equals x minus 4 times x squared plus 4x plus 16. Great, tremendous, awesome. Jeffrey, what are two numbers that multiply to 16 and add to 4, please? That's a trick question. Okay, there are no actual numbers, right? There's no numbers that, well, think 16 will be 4 and 4 and 8 and 2 and 16 and 1. In fact, there's actual no roots to that. Okay, so that's the final factor form. Now, this is so important that, do you guys want to do that again with synthetic division?
No. Long division's better.
Long division is better. Let's try this for you guys right now. You guys can try that. Right now, I'll let Michael take you through this one after. Okay. Letter B is going to be factors, I should say. And higher factoring skills.
What?
Higher factoring.
They're okay.
Then hit pause in the video. You're going to get as much time it takes for the video to be saved to the internet, and then Michael's going to take that up for you. If you're not sure what's happening,